All right, guys, I'm going to get started. Can I get a thumbs up from you guys at home that you hear me and see the board okay? Awesome. Okay. All right, so guys, today we are doing the last section in chapter 5, and it's literally a graphing calculator section. You have to have a graphing calculator in order to do this section. So please make sure you have yours out, and then I'll use mine up on my board here. All right, so in section 5.9, we're going to be building exponential, logarithmic, or logistic models from data. So in earlier chapters, we discussed how to find the linear, quadratic, and cubic functions of best fit. So you've used the calculator. You've seen we entered the data. We did it for the quadratics, right? In this section, we will discuss how to find the exponential, logarithmic, and logistic models of best fit. The diagrams below show how data will be typically observed for the three models, as well as any restrictions on the values of the parameters. So guys, basically, if you collect all this data and you plot it on a scatter plot, if the data looks like this, that's exponential growth. So they've put a formula underneath it that your graphing calculator is going to write an equation for. So it'll write an equation in the form y equals ab to the x for you. It'll calculate a, it'll calculate b. All you do is plug them into the equation. All right? If it ends up looking like this is exponential decay, and you'll use this formula, given that b would have to be in between 0 and 1 to cause that decay, and then a, your base is always, your front number in front is always positive. All right, so again, it'll write the equation for you, your calculator. It'll calculate A, it'll calculate B. All you'll have to do is plug them into the equation. All right, if you end up with data like this follows logarithmic decay. So in this case, B, the number in front would have to be less than 0, and all the data you enter, if it follows this path, it's a logarithmic decay, and it'll calculate A and B for you. So you'll literally just be plugging those numbers in for A and B into this formula. If you end up with data that models this path, this is logarithmic growth. So now A and B both have to be positive numbers. You'll plug all the data in. Your graphing calculator will calculate an A and a B value for you. You'll just plug them into the equation. And the same thing here. If your data models this, it's logistic growth. And you'll be plugging numbers in for A and B and C. And again, your calculator calculates all these things for you. You just have to plug them in. All right, so let's go to example 1. So guys, in example 1, the data in the table shows the closing price of Harley-Davidson stock from the years 1987 to 2000. In part A, using a graphing utility, draw a scatter diagram with year as the independent variable. So they want us to draw a scatter diagram where the year is our x coordinate and the closing price is our y coordinate. So guys, this is by far the worst part. You got to enter all this data into your graphing calculator. So if you remember this way back in chapter 1 or 2, this can be annoying. So everybody go to your graphing calculator. I posted on Google Classroom a list of written out steps on how to enter data, just in case you go home over the weekend and you forget. All right, if you want to enter data, first of all, let's do a couple of things. Everybody go to y equals and make sure that all of your equations are blank. Make sure nothing is stored in your y equals right now. Okay, then to enter the data, because it's going to be a little time consuming, everybody go to the stat button, which is right here off the bottom left of your arrows. So the stat button. Stat, it immediately highlights edit, and that's what we want. We want number 1, we want to edit. So hit enter. All right, you have list 1, list 2, list 3, list 4. Everybody look at me, everybody listen. We're never going to delete anything. Never hit the DEL button. If you have any data in your lists right now, I need everybody to go to second plus sign, second plus sign. If you have any data in your calculator right now, second plus sign, number 4. Number 4, you want to clear all your lists. This is how you empty your list. Go ahead.
Where's the stat line?
It's right off the arrows to the right side. To the left side of your arrows.
Oh, I see.
Stat. Okay?
Stat.
Yep. That's where you would enter, like under edit, you put your data in. So if you hit number 1, if you like under edit, you'll see your list pop up. If you have any data in there, you got to clear that data out. And the way we do it is you hit number 4, and then you hit enter, and it'll say done. And then when you go back to the stat, and the number 1 edit, your list will be empty. Please don't hit delete, because what it does is it literally deletes this column. It deletes list 1. I don't want to delete the list. I want to clear the list, okay? All right, so guys, what I need you to do right now, I want everybody to put all the X values in the data in X. You just start typing and hit enter. And then you can use your right arrow to go to list 2. But I need you to enter all this data. I'll race you. I'll tell you right now.
I have a question.
Go ahead, Jay.
How do I clear list again?
Second, plus sign. Second, plus. And then number 4 says clear all lists and hit enter.
Oh, that clear all this. Okay.
Second, plus. That's how you clear your data. We never delete. We clear the lists. All right, so everybody start putting in the X column 1. This is the most time-consuming part. It's awful. All right, and then again, you just use your right arrow to get into list 2, and now you start, make sure you put the data in right though, because otherwise it won't get us the right numbers.
Is that just 1 through 11?
I think it goes 1 to 14.
Oh.
You see your
the
list?
column. Okay, yeah.
Man, I hope I'm not making any mistakes. Now guys, can I show you something? When you get down to where X is 10, and you start typing in his corresponding Y coordinate, I think it was 11.5585, you'll notice your column automatically rounded that to 11.559. And clearly you don't want it to round it because you're like, wait, that's not the data. But if you go and you scroll back up and you highlight this number, you'll see that, yeah, it rounded it, but it really did store the number. So like what shows down here is really what is stored in there. But because it can't fit in the column, it rounded it just visually, but it literally still has that number stored. So don't worry. All right, I think I'm in. I think I'm good. I'm going to give you guys another minute. Obviously, that is time consuming. And you got to be careful because the worst thing you can do is enter in the wrong number because it'll throw all your answers off.
And what did it say to around this?
No, you can't avoid it. But if you're like, oh my God, why is it rounding all of these ones? That's not the number. If you scroll up and highlight any of these numbers, you'll see down here the number you entered is really in that column. It just can't visually show it.
Oh, okay.
So like, it's still like, because you don't want it to round. So like this number, like right here, 13, it says 13.48, but if you go up to it, it's really still that number. All right?
Okay.
Michael, I touched your calculator. I'm so sorry. That is an invasion of space. My bad.
It's okay. You do, yeah.
Okay. All right, everybody at home, can I get a thumbs up that you guys got your data in? I'm sorry, that is obviously time consuming. Okay. Okay, so that's gonna, obviously though, it takes that time, but now it's gonna do everything for us. So in part, I'm not gonna put the notes up, but in part A, it says, using a graphing utility, draw a scatter diagram with the year as the independent variable. So guys, what we did is enter the data. Now we need the scatter plot, right? So you gotta set yourself up. So there's a couple things we need to do to prep for this. And there's a couple different ways we could do it. Everybody hit the y equals. If you hit graph right now, it's like, all right, Hardy, I got all the data in, where the hell's the graph? We're not ready for the graph yet. Hit the y equals button. Everybody see up here where it says plot 1, plot 2, plot 3? You have to turn a plot on in order for them to use the scatter plot feature. So one way to turn a plot on is to use your up arrow so that the black box is blinking over plot 1. Hit enter, use the down arrow off of it, and now there should be a black box behind this plot. As long as there's a box behind the plot, that means plot 1 is on. But guys, after today, when you want it to go back to being a normal graphing calculator, please go back up and turn that plot off. You don't want it on when you're using it like a normal XY axis. We only want it on for the scatter plot. All right, another thing I want you guys to check, and this is also another way to turn the plot on, I need everybody to hit second y equals. Above the y equals, there's the stat plot button. So second y equals, I need you guys to make sure that plot 1 is on, because that's the plot we're going to use, and that plot 1 is using list 1 and list 2. Every now and again, someone's graphing calculator will say plot 1 is using list 3 and list 4. And you didn't put your data in list 3 and list 4. So you want to make sure that the lists you put your data in are the lists that this plot that you turned on is using. And I'm in good shape. I put my data in list 1 and list 2, and I got plot 1 turned on. So now I can hit graph. So now when you hit graph, it's like, oh, okay. Guys, I think we'd all agree this is exponential growth. It's getting big pretty damn fast. But we can make this even better picture. Go ahead.
What's the window that you have for that? Because my window's all messed up in the palm, like my glasses.
When you do the stat plot, it should automatically do it. All right, well, we're going to do this anyway. This should help. Let's see the next step. To make an even better picture, go to zoom, hit the zoom button, and scroll down until you get to zoom stat. It looks like it's number 9. So you can either hit number 9 or scroll down. When you hit number 9, it gives you an even, did that make it better? It gives you an even better. Now it gives you an even better X and Y axis. It's changed the window for the better. All right, so guys, we got some exponential growth going on, which means we're going to be able to write an exponential growth function for this data. And since it's showing exponential growth, you're going to want to use this formula right here. This is the formula that your calculator is going to use to write this equation. It's going to calculate an A and a B for us. All right, well, how the hell do we do that? So that's part A, guys. Part A, we graphed it. Part B says, using a graphing utility, build an exponential model. So guys, we got to build an exponential model in that form. So we're going to ask the graphing calculator to do it. Okay, to ask it to write the equation, you got to go back to the stat button. A lot of the stuff that we do is under stat. So go to the stat, but you see how edit is highlighted? I don't want to edit anything. I already put my data in. I want to calculate. So you want to use the right arrow to go over to calculate. All right, now these are where all your options are going to be. If it modeled logarithmic growth, we'd want to get the logarithmic function here. If it was a logistic model, I'd want to get the logistic model here. This is where you're going to get all of these formulas. I need you to scroll down. So guys, you see how this one says, see how number 9 says LN regression? That's a natural log regression. So if the data modeled logarithmic growth or decay, that's what you would use. That would calculate the A and the B in that formula that was under the logarithmic growth. This is what you would use for the log growth one if you had to write a log function. Hint, hint, wink, wink in your homework. The next one is your exponential regression. This is what we want because this data shows exponential growth. So we're going to want exponential regression. And then if you go down one more, I think it's one more. No, another one. Another one. There's logistic. So if it was logistic growth and you had to write a logistic model, you would ask it to calculate a logistic. But this is where they are all. Natural log, exponential, and logistic. Those are the 3 ones that you need for your homework. Okay, so we're going to go to 0, exponential. Hit enter. All right, this is important. and I put this in the list that I showed you on Google Classroom that I posted. All this is up there. If you have to look back and say, wait, how'd she do that? It's all written out in steps on the list that I posted on Google Classroom. All right, so guys, our X list was list 1, right? That's great. You can either hit enter or just down arrow. It doesn't matter. Y list, list 2. That's great. That's where our data is, right? So again, you can either hit enter or down arrow. Frequency list, we're going to leave that blank, so just down arrow or enter, don't worry. You got to get to the store regression equation. Okay, this is asking you. The calculator is about to write an exponential function for you. It's about to calculate an A and a B value. Do you want the graphing calculator to automatically store the equation it's about to write you in Y1? Yes, I do, because then I don't have to type any of this in myself. So you do want it to store it, because guys, we're going to get some ugly numbers for A and B. So we're going to ask it to store. This is how you ask it to store it. I need everybody go right here, have the box right there, hit VARS, V-A-R-S. And I wrote this down in the steps that I posted on Google Classroom. Hit VARS. And then I need you to right arrow over until YVARS is highlighted. Okay? All right. Now I want you to hit enter for number 1 function. Hit enter. And I would like it to store it in Y1. I mean, truthfully, it can store it in any of them. I just always pick Y1. So it's going to store, so just hit enter at Y1 or number 1. And now it's literally saying to you, I'm going to store this equation as Y1. So you won't have to type it in yourself. It's beautiful. It's a beautiful feature. All right, so then hit enter to calculate. And then, yes, please, we want it to calculate. Now, guys, notice how quickly that happened? It's writing you a y equals a b to the x, an exponential function. This is the a value, this is the b value. I'm just going to warn you, sometimes the natural log ones or the logistic one, it takes the calculator like 10 seconds. This won't pop up. So if you're sitting there and your calculator says logistic on the screen, and you're like, all right, but where's the a, b, and the c it's supposed to calculate? Just give it like 10 or 15 seconds. It sometimes takes the calculator a little bit of time to take all that data and calculate the A, B, and C. But guys, there it is. So now we would have to write an equation where y equals A, this number, times B, this number to the power of x. But we stored it, so it's already in ours. I just want to write these numbers down. You're not going to really need to. Just so I can quickly grab them for the next part. All right, so guys, do me a favor. Hit y equals and look how this equation is stored as y1. There it is. They stored it as y equals a times b to the x. It's beautiful. It's already in there for us. All right, so there it is. That's part B. We wrote an exponential model. All right, part C. I want to skip that just for now. Just skip part C. Part D, graph the exponential function found in part B, which is this one, or part C. Part C, we're going to write an equivalent function to this one, but in a different form. Just don't worry. Always graph this one because this is the one that's going to be stored. So guys, hit the graph button and watch how this will automatically be graphed because you stored it as Y1. So it's automatically going to graph it right over the scatter plot. So hit graph.
Does the math homework like say these steps as well?
No, I wrote them out for you on paper and sent you pictures.
Okay.
Okay? So if you follow my steps, everything's written out, and I mean to the T. Okay? All right, and there it is. So we did part D. We graphed the exponential function y equals a times b to the x. All right, and then in part E it says using the solution to part B or C, again, using the graph of the exponential function, predict the closing stock for the, guys, it's a typo. It should say for the next year. It should say in part E for the next year. So the year they left off on was year 2000 when X was 14. They want you to use this model to predict the year 2001 when X is 15. So how do you do that? You got to plug 15 into the equation you wrote. But guys, the calculator does it for you. If you want the calculator to plug a number into this function, then go to second trace, because you got to get to that calculate feature. Second trace. And I wanted to calculate a value. I wanted to calculate number 1, a value. So hit enter at number 1. And what number would you like x to be for it to plug in to this function? I want x to be 15 because that's the next year. So plug in 15 and hit enter. And it's going to plug 15 into this function for us. And according to our function, when x is 15, the year 2001, the closing stock price will be about 63.21. That's your answer. That's the answer to part E. So once you get the data in, it's literally all graphing calculator after that. You can use it to predict future values. It's all on there. Okay. Now let me go back to part C, because that's the only part that doesn't deal with the graphing calculator, and it's not asked on all of the homework questions, but I still want to show it to you. So part C asked, right now in part B, it wrote you an exponential regression in that form, a times b to the x. They want you to express this function that it wrote you in part B in this form, in our continuous uninhibited growth function. So we want to convert this formula to this form. So let me show you how to do that. Okay, so we're trying to take y equals a times b to the x and convert it to a equals a sub 0 times e to the kt. Let's make a couple easy changes right now. Well, first off, to get from there on a graphing calculator perspective, let end a be y equals a sub 0 times e to the, let time be x, because normally that's what we would use as our independent plug-in variable. Let it be that. All right, so now we're really trying to make this become that. So I want to know, when does a times b to the x, and remember guys, you already know who a and b are. I don't know if you can see this over here. We already found a and b, our graphing calculator did. All right, so we want ab to the x to equal a sub 0 times e to the kx. We're trying to write this in an equivalent form. Well guys, hold the phone. If x was equal to 0, right, at the start value, if you will, then this would be a times b to the 0 equals a sub 0 times e to the k times 0. Guys, who's b to the power of 0? What's anything to the power of 0? 1. What's 1 times a? A. I hope we all know that. So if b to the 0 is 1, 1 times a, it's really just a when x is 0. Equals, guys, what's k times 0? 0. What's e to the power of 0? 1. What's 1 times a sub 0? So really, at the end of the day, a and a sub 0 are already equivalent. So the number I found for a, we can also use for a sub 0. So that's going to be a really easy transition. Whatever number I have for a, I'm also going to use it for a sub 0. So really, it's the whole e to the kx and the b part that we got to figure out. All right, so if a and a sub 0 are equal, now we have this. Okay, well, a and a sub 0 are equal, so they can basically just divide out. So now you have b to the x has to equal the e to the kx part of the formula. So let me write it like this. It's a base b to a power of x that has to equal e to the k to a power of x. So guys, if this base to a power of x equals that base to a power of x, what do b and e to the k have to be to one another? They have to be equal. So b has to equal e to the k. And we know B. B is this number right here. 1.402,763,529 equals e to the k. You gotta solve this for k. We need a k to plug into that formula. It's the only missing value that doesn't convert over. Well, how do I solve this for k? Natural log both sides. The natural log and your base e cancel, and k will be equal to whatever the natural log of that number is. So ask your calculator, what's the natural log of that number? All right, so now we have a k value, and we already know who a sub 0 is. We have a sub 0 is equal to the original a value, and we have k is equal to this number. Now we can write an equivalent equation. So y will equal a sub 0 is equal to a, so it's this number. I think they tell you to round to like 4 decimal places on the homework though. All right, so there's my a sub 0 number because it was the same as a, times e to the kx. K is that number right there. And that is an equivalent equation to the one they wrote you in ABX form. Yes?
Can I take a photo of this?
Absolutely. Again, it's Michael, it's going to be in the filled in notes that I send you. There will be a picture of it on Google Classroom. All right, so guys, if you were to type this equation into Y2 and hit graph, this is the exact same graph as the one that we stored in Y1 because they are equivalent equations. They're just in different forms. One's in your exponential form and one's in your uninhibited growth form. But I'm telling you right now, if you type this into Y2 and hit graph, it's the exact same graph as the one they wrote us in Y1. All right? All right, so guys, here's what's gonna happen. On your notes, the second example is a logistic example. I knew I wouldn't have time because this just takes up way too much time. So I did example 2 all the way out with every little detail written down, and I'm gonna post it on Google Classroom. So you guys can try example 2 on your own, following my steps. It's literally almost identical to this. You just gotta put new data in, and then instead of asking it to find an exponential regression, you have to find a logistic regression, all right? And then on your homework, I gave you 3 problems. One's an exponential, one's a logistic, and one's a natural log. And they're literally just formulas that you're gonna ask the calculator to calculate. So tomorrow, I'm gonna have you guys work on that homework in class. But happy Friday. I'm not gonna make you come to a Google Meet. Tomorrow's assignment will just be work on that homework. If you need help, just shoot me a text and I'll jump on with you. But otherwise, tomorrow, try example 2, following my work. I did it all for you to practice. And then try the 3 homework problems. And then the homework for 5-9, I didn't make it due until Sunday night. So you'll have Sunday up till Sunday night to get it done. Are you guys okay? Everybody's all right? All right. All right. And again, if anything's troubling you on the graphing calculator, guys, I really am posting very detailed pictures of these problems on Google Classroom. I highly recommend reading those, okay? All right. If you don't have any questions, I think we should be good to go. Let me just double check the meet attendance.